Hi, hello, welcome to Knowledge Center. This is my first video wherein I am going to provide you the solution for KPTCL question papers. And these question papers is related to the junior engineer post. And this question paper is asked in the year 2017. So let's begin with the very first question from the junior engineering question paper which has been asked in the year 2017. So here you can look into the question. If the ratio of the ages of Mini and Tini is 5:6 at present, so they have given the ratio of the ages of Mini and Tini at present, and 15 years from now the ratio will get changed to 8:9. Then find Tini's present age. So they have given some 4 options like this. To solve this kind of a problem, there is a simple logic which you need to follow. First, write down the present ages of a Mini and Tini. As we have a ratio here, we don't know actual age of them, so we can take it like this. At present the age of Mini is 5x and age of Tini is 6x, where x is the unknown factor. For example, say if x is 4, then the age of Mini will be 4 into 5, that is 20, and age of Tini will be 6 into 4, that is 24. Then we get it actual ratio, so we can take it as an x as an unknown factor if you need to find that value now. So at present this is the age. After 15 years from now their age will be added, means it will be plus 15. So we can note it down as 5x plus 15 will be the age of Mini and 6x plus 15 will be the age of Tini after 15 years. And they have given one more information, that is the ratio of their age after 15 years will be 8:9. So we can take the relation like this. The ratio of age after 15 years will be equal to 8:9. So we can take it as 5x plus 15 by 6x plus 15 equal to 8 by 9. Once we take this, we can find the unknown parameter x. So just cross multiply it, 5x plus 15, and this is numerator, this is denominator. So this goes to the RHS side and 9 will come to the LHS side. So 9 5s are 45x plus 9 15s are 135 equal to 8 6s are 48x plus 8 15s are 120. That's how we have cross multiplied it. Once we simplify this, we get it as 15 equal to 3x and x equal to 5. So this is how we have to find the value x. Okay. So once after getting this value x, we can find the present age of individual, that is Mini and Tini. But in question it is asked that what is the present age of Tini. So just need to find present age of Tini. So just 6 into 5. We know that present age of Tini is 6 into x, where x is 5. So 6 5s are 30. Therefore the present age of Tini is 30 years. Option B will be the right answer for this. You can also find the present age of Mini, that is 5 into 5. So it would be 25. So the way of getting answer is important here. I hope this is very clear. I have also made a videos on assistant engineering question papers. Those who are interested, they can also watch it in my YouTube channel. The link will be given in the description. And also you can search as a Knowledge Center by Sharan sir. So you get all my videos over there. Now let's move for the second question. Find the smallest number which will leave remainder 5 when divided by 8, 12, 16 and 20. So these are the numbers they have given. You need to find the smallest number which will going to give you remainder 5 when divided by the given numbers. So 8, 12, 16, 20. One thing you need to understand here, all these numbers are divisible by 4. So if we need to find the smallest number which is divisible by any of these numbers, and remainder should be 5. So you can start with the 8. If you are getting answer for any one, same answer will be there for the rest of the conditions. So let us begin with the 8. So option A is 265. Let's divide it. 265 by 8 is 33 and the remainder will be 1. So that would not be the answer. Next we go for 245. 245 by 8, the remainder will be 5 because the answer will be 30. The quotient will be 38. 3 is 24 and if you put 0 it will be 240. So remainder will be 5. So here we got the remainder as 5, but we cannot fix the answer here because we have an option which the question is the smallest number which will leave remainder 5. So cross check it for 240 and 235 also. So 240 by 8 will be 30 and remainder will be 0. Similarly 235 by 8 will be 29 with remainder 3. So here option B will be the answer. You no need to cross check it for 12, 16 and 20, because among these options only in B option we are getting remainder as 5, and definitely that will get the same for remaining numbers, because all those remaining 12, 16 and 20 are divisible by 4. So we get the same answer there. Even though I am giving the solution for that. 245 by 12 is again give the remainder as 5. 245 by 16 will also give the remainder as 5. You can cross check it. 15 into 16 will be 240 plus remainder 5. 245 by 20 will also give 12 with remainder 5. So option B is the answer for this question. Now let's move for the third question, where the amplification factor of a triode operating in the linear region depends strongly on 4 options they have provided. So this is about triode. So just understand the concept of triode here. Triode is nothing but it is just an advanced version of a diode. In diode we have PN junction, one is anode, another one is the cathode. Now in between we are placing a grid. Okay, so there are 3 terminals and grid is used to control the flow of electrons. Okay, so it is generally placed nearer to the cathode. The grid will be placed nearer to the cathode, and when we apply if we don't apply any voltage to the grid, then there will be a flow of current between the anode and cathode. Easy flow of current will be there. That is for amplification. If you apply negative voltage for the grid, then it will repel the electron from the cathode, means the number of cathodes electrons moving from cathode to anode will be less, so we can say the anode current will be reduced. If I apply the positive current from the for the gate, then it will absorb all the electrons. Okay, so that is how it is going to control the flow of current in between the anode and cathode. Now the question is, if you want to amplify the signal, then what should be the condition here among these 4? So we can say very simple that if you remove this gate from this anode and cathode, at that time we can have easy flow of current. So the amplification will be high due to unavailability of a gate. So we can say that option B, that is the separation of the grid from the cathode and the anode, will give you the better amplification factor in the linear region. So we can go for the option B here. Next question is again related to the age factor. Slight change we have, but in the same question they have asked twice regarding the age. The present ratio of ages of A and B is 4:5. 18 years ago this ratio was 11:16. So it is 18 years ago, it's a past. Okay, find the sum of their present ages. So they have given 4 options here. First let us find what is the present age. The present age can be taken as they are given in terms of ratio. So I can write it as 4x is the present age of A and 5x is the present age of B respectively. And 18 years ago, so when you go back to the 18 years, their age will be reduced by 18. So we can say that present age is 4x minus 18. So 18 years ago their age will be 4x minus 18, and age of B will be 5x minus 18. If I take the ratio of them, it is given as 11/16 or 11:16. So I can relate it like this. The ratio of the age of A by age of B is equal to 11/16. So solve this. You will get 16 to the LHS side and 5x minus 18 to the RHS side. Cross multiply it. 16 4 is 64 minus 16 18 is 288 is equal to 5 11 is 55x minus 18 11 is 198. So take that x to the LHS side. 64x minus 55x is equal to minus 198 plus 288. Once you simplify this, we get 9x equal to 90. Therefore x equal to 10. And here you need to find the total sum of their present ages. Okay, so present age is 4x and 5x. You substitute that x value as 10. So we can say that sum of the present ages will be 40 plus 50. X is 10, so A will have 4 into 10, that is 40. B will have 5 into 10, that is 50. Total 90 years. The sum of total of their present age will be 90 years. Option B. So among the top 5 questions, there are 2 questions related to the age factors only. If you understand the basic concept how to write these equations, then you can solve the problems here. Now let's move for the last question for this video. That is, a parallel plate capacitor having charge Q on each plate is connected to a battery. Now dash. So these are the options they are given. So this is a 2 parallel plate, both having a charge of Q on each plate. Okay, so if we have 2 plates and on the surface of 2 plates, if we have positive charges like Q here, the voltage between these two will be 0. Means voltage between the 2 plates will be 0 if there is no battery connected. Okay, when battery is not connected, the outer surfaces will have charge Q as shown in the figure, and inner faces of the plates will have 0 charge. Now the question is, if the battery is connected, here battery is connected. So in this from this situation, if I connect a battery, what happens to that system? Let's look into that. See, when we connect a battery will have positive and negative terminal. So it will try to maintain the 0 voltage between these 2 plates. Okay. So when battery is connected, then the 2 plates of the capacitor, the charges on the plate redistribute in such a way that the potential difference between the plates should be equal to the EMF of the battery. Okay, so we can say that the facing means opposite faces what we have here. The facing surfaces of the capacitor will have an equal and opposite charges, because we will have a positive and negative for the battery. So the facing surfaces of the capacitor will have equal and opposite charges. That would